Yes, I did record the session. So one of the things that's a little bit weird about the recordings recently, you'll be able to hear my audio, but it's not always capturing the screen captures, but I'm posting all of my answers. So all the answers will be up and you can listen to the audio. I apologize. I don't know exactly why it's not screen capturing the way it's supposed to. All right, 18. Just a little bit too far. Okay. Let's go ahead and do the whole problem, but we'll focus on D and E at the end. So on part A, what are they asking us to do with these two complex numbers? They're asking us to add them. So when I'm being asked to add two complex numbers, I'm going to line up the like terms. So I'm going to recopy 4 plus 7i. Underneath that, 2 minus I. And then I just add them together. I combine the like pieces. So I add the 4 plus 2 part, and I get what? 6. And then 7i plus negative 1i. 6i. What are they asking us to do on part B? What operation? Subtraction. So I'm going to take this negative and I'm going to distribute it to both pieces. So negative 5 plus 2i. After I distribute that negative, I'm going to do it just like I did part A. I'm going to line them up with like terms underneath each other, and I'm going to combine those like terms together. So I have negative 1 and a negative 5i that I'm going to combine. Negative 6 and 3i and 2i. 5i. Right. What operation are they asking for on part C? Multiplication. So I'm going to take this 3 and distribute it to both pieces. So I get 6 plus 15i. And then I take the 2i and I distribute that to both pieces as well. So 2i gets distributed to 2, so plus 4i. 2i and 5i gives me 10i squared. Do I have any like terms that I can combine? Yep, 15i and 4i. What do I get when I combine those two? 19i. There's something else kind of interesting going on. This I squared right here, I can replace that. Does anybody remember what I squared is equal to? Negative 1. So I have plus 10 times negative 1. What is 10 times negative 1? Negative 10. So now I have two like terms again. I have a 6 and a negative 10 that I can combine together. What is 6 and negative 10 combined? Negative 4. So negative 4 plus 19i. All right, now D and E. One of the important things for us to remember on both of these is that if I squared is equal to negative 1, I is equal to the square root of negative 1. This idea right here and this idea right here are ones that I would make sure to have written down on my cheat sheet. All right, so when I see this negative underneath the square root, I'm going to take it out as an I. So I square root of 25 times I square root of 4. I times I gives me I squared. And then these pieces underneath the square roots, I can multiply together underneath the square roots. So I multiply the outside parts, the I and the I, and I multiply the inside parts. Now I squared is equal to negative 1, but what's 25 times 4? 100. What's the square root of 100? 10. What's negative 1 times 10? Negative 10. For part E, I'm going to walk through it in almost exactly the same way. I see these negatives underneath the radicals, so I'm going to take those out as i's. So I have I square root of 9 times I square root of 8. I multiply the outside pieces, I times I get I squared. I multiply the inside pieces, 9 times 8. What is 9 times 8? 72. So underneath my square root, I have 72. I squared, though, I replace with negative 1. Now here's where it gets a little bit different, because over here I had the square root of 100, and you guys could tell me what the square root of 100 was. Is 72 the same way? Can you tell me the square root of 72? No. So we're going to have to try to break this down. So I'm going to do that in this open space over here. So square root of 72. What kind of number is 72? Even or odd? Even. So what has to go into it because it's even? 2. This would be 2 times what? Grab a calculator if you don't know. Do 72 and divide it by 2. 36. Can I break apart a 2 any more than that? No. What do you notice about 36? It's underneath my radical. Do we know what the square root of 36 is? 6. So this is square root of 2 times the square root of 36. So the square root of 2 times 6. So I'm going to replace this with this. This is 6 square root of 2 that is getting multiplied to a negative 1. So I have negative 6 square root of 2. What else would you guys like to see or go over? You said 22? Yep, absolutely. All right. So on number 22, it says to solve the system. We have 3 ways of doing that. We can solve a system by graphing. We can solve a system by substitution. Or we can solve a system by elimination. If they don't give you a graph, I probably wouldn't use solving by graphing. To use solving by substitution, I want either x all by itself on one side, or I want y all by itself on one side in at least one of my equations. Do I have anything that looks like that? Then I would choose the substitution method. So I'm going to take this x squared right here, and it's going to take the place of the y in that second equation. So I'm going to have x squared equals 2x plus 8. And then from here, I want to get everything on the same side as my x squared. I need it set equal to 0, but I don't want to minus the x squared from both sides because I never, ever, ever want my x squareds to be negative. So I'm going to minus 2x from both sides. So I have x squared minus 2x equals 8. Do I have it equal to 0 yet? What do I still need to do to get it equal to 0? Subtract 8 from both sides. X squared minus 2x minus 8 equals 0. Well, how am I going to solve something like this? What do I need to draw to help me solve something like this? An X and a box. So I'm going to draw my area model. X squared goes up here. Negative 8 goes down here. So I multiply A and C together. 1 times negative 8. Two numbers that multiply to give me negative 8. But when I add those same two numbers, I get negative 2. What will do that? 2 and 4. 2 times 4 gives me positive 8, so we're close. Negative 2 and 4, both of them negative? Negative 4, just one of them negative. Since my B value is negative, the bigger number in that pair is going to be the negative 1. So then I'm going to pull out the things that I can from each pair. What can I pull out of x squared and negative 4x? What do they have in common? X. What about 2x and negative 8? What do they have in common? What goes into both of them? 2. Positive or negative 2? What are we touching right here? Touching a positive. So I'm going to take out a plus. So x plus 2 is a factor. Now we're going to go vertically. X squared and 2x, what do those have in common? X. And negative 4x and negative 8, what do those have in common? Negative 4. Again, we pull out the sign of whatever we are touching. So x minus 4. Okay, so I have x plus 2 and x minus 4. I need to solve both of those for x, but then I'm also going to have to find y because this is a system. It said write your solutions as ordered pairs, x, comma, y. So for x plus 2 equals 0, I'm going to minus 2 from both sides. X equals negative 2. So I know that part of my ordered pair, negative 2 something. How am I going to find the y part of the ordered pair? Substitute. I can substitute into either the top equation or the bottom one. Which one do you guys feel like using? Top one sounds good. Y equals x squared. So I'm putting in the negative 2 in the place of the x. What does it mean to square something? Times it by itself. So y equals negative 2 times another negative 2. Positive 4. That's the y part of my ordered pair. So there's one solution. Then I need to come and do this with my other one. So I'm going to add 4 to both sides. So x equals 4. Now I know the x part of the ordered pair. Still need to find the y part. Do you guys want to use the top equation again, or do you want to use the bottom equation? It does not matter. You want to use the top one again? Okay. Y equals, I'm going to take x and put it in the place. So we're taking 4, putting it in the place of the x. So y equals what? 16. Here's my other solution. All right. What else would you guys like to see? 23 and Demetrius? So 19 and 23. Let's do 23 next since I'm right there, and then we'll go backwards and do number 19. Great. So I'm going to get everything I need to from just this first piece right here. What is my leading coefficient? -2. What is the degree? 3. What is my domain? Positive infinity to negative infinity. Anytime I have a polynomial function like this, it is continuous. And one of the things that we know about continuous functions is that they go forever to the left and to the right. So my domain is negative infinity to positive infinity. You told me that we have a degree 3 polynomial. What does that tell me about my ends? Ends go opposite ways. Well, if one side points up and one side points down, or even if I flip it around the other way, my ends are going opposite ways, right? What's the lowest it ever goes? Yep. Negative infinity. What's the highest it ever goes? Positive infinity. So my range would be negative infinity to positive infinity also, because my ends go opposite ways. Well, which side is going up and which side is going down? Where do I look for that? The right side. Which piece over here tells me about the right side? What do you mean by second one? Which piece is going to be one of these pieces tells me about my right side? Leading coefficient. This is right side behavior. What kind of number was my leading coefficient? Negative. So what is the right side doing? Going down. Which one of these means the right side? +1, because the right side of my x-axis is where the positive numbers live. So this is the right. You guys told me that it's going down, so that would be negative infinity. Which means the left side is doing what? Left side is going up. All right. Number 19 is going to be the next one that we look at. Oh. There we go. We're supposed to determine the value of the discriminant. So let's go ahead and do 19, 20, and 21 because they're all the exact same kind of problem. They're all discriminant problems. Something you might want to make sure to have down on your cheat sheet is this information right here. The discriminant to find the discriminant, we do b squared minus 4ac. If I plug the numbers into b squared minus 4ac, and I get a negative number back, then that means there are two complex roots. If I sub into the discriminant and I get a positive number back, then there are two real roots. The only other possibility is that when I substitute in, I get a 0. That means 1 real root. So it's either going to come out to give me a positive number, a negative number, or 0. Before I can substitute into the discriminant, this right here must equal 0. So how do I get that equal to 0? Minus 10 on both sides. So I have x squared plus 2x equals 10. I'm going to minus 10 from both sides. X squared plus 2x minus 10 equals 0. So what are we using for A? What are we using for B? What are we using for C? 1, 2, and negative 10. 1 for A, 2 for B, and negative 10 for C. Anytime I substitute in for my discriminant or into quadratic formula, I use parentheses anytime I make a substitution. What do I put inside the first set of parentheses? What are we going to square? 2. What is 2 squared? 4. And then I'm going to bring down my minus sign. I have 4 times what 2 numbers? 1 and negative 10. Well, what is 4 times 1 times negative 10? Negative 40. What happens right here? Yeah, turns into addition. Oops. So I have 4 plus 40, which gives me 44. So what does that mean about my roots? 2 real roots, because I came up with a positive answer. I want you guys to try number 20 on your own. Same exact process. Try number 20 on your own. You write the math. We do that. You just like keep going and then subtract it. You can do that, but this would still need to go in the front then, because that's your x squared. So that would be A, that would be B, and that's going to be your C. Yes, sir.
Subtract this. So that's
Absolutely. And while you guys are working on this, I did just want to let you know, I'm not sure if I made this announcement in this class period or not, but this is a class where if you pass the final exam, you pass the class. So even if you're sitting in a spot where you're not passing the class right now, there's still the possibility to pass for the semester by getting a 60% or higher on this final exam. So it is really important that everybody still continue to stay really invested in the class so that we get our 60%. So I can subtract x squared from both sides, but then it's really important that I keep things in order. Which of these 3 pieces would have to go at the front? Yep, that negative x squared. So minus x squared goes first. And then plus 2x, because the 2x was a positive, and then minus 4. Now I can go through and identify A, B, and C. What is A? -1. So -1 is our A. What is B? 2. What is C? -4. So my B value is 2. When I take that and I square it, that gives me what? 4. Bring down my minus sign here. 4 times -1 times -4. I have a negative times a negative, so I have 4 minus 16 here. Because if I'm just looking here, 4 times -1, that would be -4 times -4, that would be 16. And I brought my minus sign down there. What is 4 minus 16? Close. -12. So what does that tell me about my roots? 2 complex roots. Try number 21. Almost exactly like what we just did on 19 and 20. Try number 21 on your own. Stay with me, sir. You need to practice on your own. The only way you're going to get better at it, dear. What happens on this one? Minus 4x on both sides. I have to keep them in order, so the x squared stays first. 4x squared minus 4x plus 1 equals 0. Plug into my discriminant formula. What am I putting in for B, the thing that I'm going to square? -4. What are we putting in for A? 4. And for C? 1. What does it mean to square something again? Multiply it by itself. So -4 times another -4 gives me +16 minus what? 16. So what is the value of my discriminant? 0. What does that mean then? 1 real root. What else would you guys like to look at? Which one? Number 6? Absolutely. Let's try to use some process of elimination. Which one of these 4 graphs is linear? C. What does quadratic mean? Quadratics make what kind of a shape? A U shape. Which one of these has a U shape? B. So B is quadratic. All right, so we've used this one, we've used this one. Piecewise looks like a whole bunch of different functions put on the graph together. Which one matches that description? A. And here's how I remember what an absolute value looks like. It's absolute what again? Value. And it looks like a V. Absolute value looks like the letter V. All right. What else would you guys like to see? 7. All righty. Okay, so on number 7, the first thing I'm going to look at is these last numbers. This tells me how far up or down to look for the vertex. So what are the ones that could possibly go with these 2 equations? Which graphs could potentially go with these 2 on the left, the ones with the -4s? A and C. And now I just need to decide which one goes with which. Do you guys see how I have some things inside parentheses here? These look a lot like factors, right? What do we always do with factors? Set them equal to 0. X minus 4 equals 0. How do I solve that for x now? Add 4 on both sides. Well, which one of these, A or C, has an x part at +4? C. If I take what's inside parentheses down here on the bottom one and I set it equal to 0, x plus 4 equals 0. I minus 4 from both sides. X equals -4. So now I'm looking for an x part that is -4, and it went down 4. Which one would that be? A. All right, so I know that these 2 go with B and D. That top one, x plus 4 squared plus 4, shut it off and put it away. Would that go with B or would that go with D? D. Because when I take what's inside parentheses and I equal it to 0, it's going to tell me an x of -4. Anytime I see things inside parentheses, I take those parentheses and I equal it to 0. So this one has to be B. Yes, sir. Yes. Yep. Our H value is always opposite, just like our factors. Our solutions are always opposite of, like our factors and our solutions have opposite values. Yep. That is our H value. You're absolutely correct. We probably have time for one more, depending on how long it takes me to go through it. What else would you guys like to see? Which one? Number 10? Absolutely. Let's go look at it and see if we have time to get through it. Oh, yeah. Do you guys see those bars in this problem? Absolute value, that's actually exactly what that is. This is absolute value. What does absolute value mean? How far away it is from 0. Is my absolute value isolated here? Is it all by itself over there on the left? First thing I have to do is get it all alone. Who's on the outside of the absolute value? 3 and a -8. Which one has to go first? Which one's easiest to get rid of first? The -8. How do I get rid of a -8 or a -8? Add 8 to both sides. All right, so I have 3 and then the absolute value symbol, x plus 2 equals 18. How is that 3 attached to the absolute value? What operation's happening there? Multiplication. How do I undo multiplication? Divide it on both sides. All it's going to do on the left is cancel out the 3. But on the right, I'm taking 18 divided by 3. What is 18 divided by 3? 6. What does absolute value mean? How far away it is from 0. If I tell you I'm standing 6 units away from 0, where could I be on the number line? At 6 or at -6. So where I'm standing, x plus 2, is either at positive or -6. So I have 2 cases. In case 1, x plus 2 is at +6. And in case 2, x plus 2 is at -6. In case number 1, what do I do to get the x all alone? Subtract 2 from both sides. So I get that x is what? X is equal to 4. In case 2, what do I do to get the x all alone? Subtract 2 from both sides. Because it was a +2, so I have to -2. The only thing that changed signs was the 6. So x is equal to what? Not 4. -8. All right, a couple quick announcements. Again, things that I'm trying to make sure that I hit on in every class. So if I've said this in here already, I apologize, but I want to make sure that everybody is clear. Your yellow cheat sheets. You guys are welcome to take those home, back and forth to class, continue working on those until Tuesday. On Tuesday, at the end of the class, before bell, I'm going to collect all of these from everybody so that I have them safe and sound in here for you for when you come in to take your test on Wednesday. Too many times in the past, people have forgotten them, or a water bottle spills in their bag and their cheat sheet gets ruined right before the test, or somebody's screwing around in the hallway and their paper gets ripped. This way, if you leave it with me, you know that it's safe, it's sound, it's not got water dumped all over it, nothing bad has happened to it. So you'll leave it with me on Tuesday, and then when you come in to take your test on Wednesday, I will have your cheat sheet for you, and I will hand that out to you and then give you your exam. Sound like a plan? Awesome.